Now moving to the third type of hybridization, the sp hybridization. From the name you can see that only one p orbital participates in the hybridization with the s orbital. Here we have the carbon 2s orbital that hybridized with one of the two p orbitals, which results in the formation of two sp hybridized orbitals, and two of the two p orbitals remain unhybridized. The hybridization of one s and one p orbitals results in two sp orbitals with 50% s character and 50% p character. The angle between the two hybridized orbitals is 180. You can see both sp orbitals are on the same plane, and the two unhybridized 2p orbitals are perpendicular to the sp hybridized orbitals. One important note is that the two unhybridized 2p orbitals are the ones form the pi bonds. Here we have two unhybridized 2p orbitals, so we expect two pi bonds. Let's look at acetylene molecule. Acetylene has two carbon atoms, each has two s hybridized orbitals and two unhybridized 2p orbitals. So for the two atoms, we have a total of 4 sp orbitals and 4 2p orbitals. Acetylene has two hydrogen atoms, each has one s orbital. Let's look at the bonds of the acetylene molecule. The sigma CH bond is formed due to the overlap between the two sp orbitals of the two carbons and the two 1s orbitals of the two hydrogens. One sigma carbon-carbon bond forms due to the overlap between the two sp carbon orbitals of the two carbons. Finally, the two carbon-carbon pi bonds form due to the 4 2p orbitals overlap. We have a total of 5 bonds, 2 sigma carbon-hydrogen bonds, 1 sigma carbon-carbon bond, and 2 carbon-carbon pi bonds.